Hi everyone, hope you all are doing well. So let's start today's video, and this is connected with the previous video. And in previous videos, as we covered what are pointers and how to use them, how to declare them, and like what are the different symbols like ampersand and strict was the other one. Then what are the uses of pointers? So in this video, we'll be covering different types of pointer, like what are the different types of pointer available to us, and we'll try to see them through an example. And this will be again C++ or C language. So yeah. So let's start this video. So first thing is like null pointer. So basically, what is a null pointer? So just read out the definition. I'll just read out the definition for you. A null pointer is a pointer that points to nothing. It is typically used to indicate that a pointer is not a valid. So what do you mean by what do we mean by nothing here? Like points to nothing. So as I said in previous video, the pointer always points to an address. A pointer always contains the address of any other variable. But if there is a case when pointer is not pointing to anything, like it is not containing address of any variable, then it is a null pointer. So how do we store nothing in the pointer? So there is a keyword in C++ and other languages, like not in C++, but in many languages null is there, null pointer, null, then like uh, none, and all these things like depends on the language you are using. So basically, whenever we store this null, so basically this pointer is a null pointer. It is not pointing to anything. So that's how we define a null pointer. And let's come to the next type of pointer, wild pointer. What is a wild pointer? So wild pointer is a pointer that points to an invalid memory location. This can happen if the pointer is not initialized or if it is used to access the memory that has been freed. Okay. So the main thing is like whenever a pointer points to a memory address that is invalid. Let's say what I mean is basically let's say a pointer was pointing to a variable. Let's say a variable was there, it has some address, and now someone came and let's say killed this variable, but pointer does not know whether whether this address has been killed, and it is still pointing to that particular variable. Then this will be a wild pointer. So basically, here let's see through an example. So int a strict wild pointer. So here we declared a pointer variable using the strict symbol, and it is going to store the value of int. And we try to store like wild pointer equals to 10. So wild pointer equals to 10. So we are basically giving a 10 value to a pointer. Okay, I mean we are addressing the value 10, which is a constant, which does not have any address, because the 10 is a constant here, right? It is not being stored in any variable, and we are just assigning it to our pointer. So that is not a valid address. Like the 10 does not have any address. So basically what we said here, like pointing to invalid memory location, so it does not have any memory location. So basically this wild pointer is a wild pointer now. Or the other case would have been this one, like which I already said, that let's say we had already had one variable, let's say a, which has value 5, and the pointer p was pointing to a, but someone came and in middle of program we just freed the address occupied by variable a. Then pointer p will be pointing to invalid memory location, so we'll call that pointer as a wild pointer. Then dangling pointer. Let's come to a dangling pointer. A dangling pointer is a pointer that points to memory that has been freed. So again, this is here, this is here. But the only thing is like you will see it through an example. This can happen if the pointer is used to access memory after it has been freed. So basically, when pointer is what's the difference? So here also we said like if a pointer is pointing to memory address that has been freed, and here also we are saying that memory address has been freed. But in this situation, it doesn't mean that it is trying to access it, but here it is trying to access it. So that's the one difference. And the other one is like the other use case of dangling pointer is uh, uh, let's say pointer is trying to point to a variable which is nowhere in the scope. Let's say we declare a dangling pointer here, and then this is again, like you might know, then this is again a separate memory, separate scope within the scope. Basically within the function, this is a separate scope, so anything declared inside this one can't be accessed outside this particular scope. So basically we declared dangling pointer here, and then we declared a variable num here, then we assign the address. So till now everything is fine, like there is no issues, nothing on this side. We can access num, we can access the address of num, we can access the value of num, that is fine, that's okay. But once we go out of this scope, so num goes out of scope because num is no more in scope. And when we are trying to assign this value, so that's not the correct way of using the pointer, because now the pointer, like the dangling pointer was storing the value of, like dangling pointer was storing the address of num variable, which is no more in the scope, no more no more in the code. Like code doesn't know if there was any such variable. And when we are trying to define, when we are trying to change the value of that particular address, then it will come into a situation where it will be declared as a dangling pointer, because it is trying to access the value of address which is no more there. So that's a dangling pointer. Then complex pointer. So basically complex pointer is also known as a double pointer, then some people call it pointer to pointer. So like depends on what term is being used, but the definition is same. Like it is not going to be changed. So complex pointer is a pointer that points to another pointer. This is because this can be used to create linked list and another data structure. So basically let's try to understand what it means. So if you remember, like earlier I said that pointer is a variable that is used to store the address of another variable. Pointer is a variable that is used to store address of another variable. So what it means, basically pointer is again a variable, right? So there can be a second pointer which can store the address of this particular pointer. So let's say we had this variable integer number 10, so no issues. Like number is a variable which is having the value 10. Like we have a box for this one which is having 10 here. Then num here, let's call it num, then it's address of x, let's call it x. Then here we defined a pointer p, pointer 1 of type integer, and it is storing the address of num. So that's okay, like it is pointing to address of num. And num p1, let's call it p1, that's also okay. Like, but p1 is again a variable, right? So p1 will have its own box where it will having the address of 10. So if it was x, then again it will having some address, let's call it y. Then we define a pointer 2, but here if you see that we have two asterisks. So basically what does it mean? Like it means that pointer 2 is a pointer variable, which is going to store the address of another pointer. So whenever we want to store the address of another pointer, then we use the two asterisk symbol. So basically pointer 2 can't store the address of num. Like if you try to store the address of num, it will fail. Like if you try to write pointer 2 equals to m% num, it will fail. Like the code will not compile, because pointer 2 is supposed to store the address of another pointer variable but not the normal variable. And then it is storing the address of pointer 1. So what, let's say if we had the box of p2, then it will be like something like this, p2. Then what is the address of this p1? Let's, so it is y, it will be stored here, and there's some address. So basically this is a kind of like flow. So p1 was storing the address of num, p2 is storing the address of p1, and so on. So using the p2 we can store, we can access the value of 10, we can change that value, like that's also possible. Let's say if we try to print strict ptr2, then it will print the value stored at that address. So basically it will print the value that is here, that is address of 10, that is x. But if we try to print a strict let's say strict p2, then what will happen? So p2, what is p2 storing? Y. What is the value at that address? So it is x. So one asterisk is cancelled. Now again there is one asterisk. So now p2 is string, p2 is storing x, and when we try to asterisk on that one, it will print the value of uh, value stored at address x. So what is that? 10. So that's how we can access it. So we'll cover the next types of pointer in next video. So see you then.